we are going to be observe how the carbon-carbon triple bond is going to be formed. So carbon-carbon triple bond, that means hybridization will be the sp hybridization. So we are going to be see the representation by using this diagram. In case of the carbon-carbon triple bond, the hybridization of the carbon atom will be the sp. So what is the hybridization of this carbon atom? Either this carbon atom or this carbon atom. Hybridization will be the sp hybridization, whereas the bond angle will be the 180 degree. If you are going to be see that hybridization of the carbon will be the sp, whereas the bond angle will be the 180, which has been already denoted it here, and the geometry will be the linear. So in case of the alkyne, the representative example will be the ethylene or the acetylene. Hybridization of the carbon will be sp, bond angle will be the 180 degree, and geometry will be the linear. So we are going to be see during hybridization how the overlapping of the atomic orbital is going to be takes place. As it is a carbon-carbon triple bond, so out of which one is a sigma bond and two pi bonds are there, and there is a sigma bond between carbon hydrogen as well as another carbon hydrogen atom. So we are going to be see all in detail which orbital or which atomic orbital or the hybridized orbital are going to be involved during the formation of the overlapping. So in case of the ethylene molecule, a carbon-carbon sigma bond, which is going to be formed by sp hybridized orbital of one carbon atom and sp hybridized orbital of the another carbon atom will overlap and will give the formation of the sigma bond. So in triple bond, one is sigma bond and two pi bonds are there. So this is the sigma bond formation, whereas during sp hybridization of the carbon atom, 2p orbital like 2py and 2pz remains unhybridized. So during that case, one of the 2py orbital which is going to be shown into like this yellow, one of the 2py orbital which is unhybridized of one carbon atom, and another carbon atom which is also going to be contain the unhybridized 2p orbital will be combined, will give the formation of one pi bond. So we can observe it here by the yellow line. Overlapping is there on above the plane as well as the below the plane, whereas another unhybridized orbital which is a 2pz. So during pi bond formation, a 2pz orbital which is represented by both the carbon atom in a black will give the formation of the pi bond. So second pi bond in ethylene molecule or ethane molecule will be formed by 2pz orbital of one carbon atom and 2pz orbital of the another carbon atom. So this is how sigma and pi bonds are going to be formed in case of the alkyne. Whereas a CH bond, there is a two CH bonds are there. So both the CH bonds are formed by sp hybridized orbital of one carbon atom and s orbital of the hydrogen atom. So CH bond, sigma bond will be formed by sp hybridized orbital of one carbon atom and s orbital of the hydrogen atom. So this is how, so we can see there should be the sp and not the sp2. So this is the shape of the alkyne molecule. We can easily observe carbon hydrogen sigma bond will be formed by sp of carbon and s orbital of the hydrogen atom on both the side, whereas the pi bond will be formed by the py and py orbital as well as the pz or the pz orbital. So and sigma bond will be formed by sp of one carbon atom and sp of another carbon.